Hello and welcome. My name is Nader Zidan, and I'm with The Ohio State University's STEM Exploration and Engagement ACT video group. And today, I'm going to be talking about trigonometry on the ACT. Now, out of the 60 questions in the math portion of the ACT, only 4 to 8 of them are really only about trigonometry, so it's not a huge part. But these questions may seem really confusing, and if you get stuck on them, they'll eat away your valuable time. Let's dive right into it. So, we know with triangles, we have 3 sides. 2 of them are the legs, and 1 of them is the hypotenuse. And the hypotenuse is always the longest side, and this is for specifically right triangles. So, with right triangles, there's a really neat property called the Pythagorean Theorem that relates the length of the 2 legs with the length of the hypotenuse. And that is that a squared plus b squared is equal to c squared. And all that means is that if you had a triangle like this one right here, it means that the side length a squared plus the side length b squared is equal to the hypotenuse length c squared. Using this property, it's really helpful to determine all sorts of neat properties and all sorts of features about triangles. Another neat thing that we can use for triangles is the trigonometric properties for angles. And this is what the mathematicians have an acronym, and they like to call it Sohcahtoa. The SO part stands for sine is opposite over hypotenuse. And all this means is that if you had some angle, let's say this angle right here, the sine of that angle is the magnitude of the opposite side length, in this case b, over the hypotenuse c. So sine is just opposite over the hypotenuse. The counterpart of Sohcahtoa stands for cosine, is adjacent over hypotenuse. So if we were looking at the same angle, this angle right here, the cosine of that angle would just be the side length of a divided by the hypotenuse c. Now it's important to remember that the adjacent never refers to the hypotenuse. The adjacent always refers to one of the 2 legs on the triangle, and the same goes for the opposite. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now the TOA part stands for tangent, is opposite over adjacent. And all that means is that if we were looking at our same angle, the one right here, the tangent of that angle would be the side length b divided by the side length a. And that's really all it. That's just Sohcahtoa, sine, cosine, and tangent. And putting all of this together, they really help us understand and be able to solve for different parts of the triangle. Let's do a demo problem and see how it all fits together. If we had a triangle ABC, and we're given that the side length AB is equal to 5 and BC is equal to 2, we want to know what the tangent of the angle B is. Now the first thing is to recognize is the angle B is this angle right here. And tangent, remember, Sohcahtoa, tangent is just opposite over adjacent. So it means that we want to take our opposite side, or AC, and divide it by our adjacent side, BC. Now we know BC, but we don't know AC. But we also know the hypotenuse. So using the Pythagorean Theorem, we can solve for the side length AC. So a squared plus b squared is equal to c squared. If we move the b squared over, we get a squared is equal to c squared minus b squared, and we can take the square root of both sides to solve for just the length of AC. So we have AC is equal to our hypotenuse, 5, squared, minus our other side, 2 squared. And we take the square root of both sides, so we get the square root of AC squared is the square root of 25 minus 4, and then we get that to be just the square root of 21. So we know that the side length AC is equal to the square root of 21. So our tangent of B is just 21 divided by 2. Thank you for watching this video. I hope this has been a helpful tutorial in trigonometry, and good luck on the math portion of the ACT.